Check out these strange and interesting engines that I bet you didn't know existed. The Sabre engine. The makers of the Synergenic air-breathing rocket engine, Sabre, have secured the necessary funding to fire up their hardware by 2020. The Sabre engine is designed to use jet propulsion to power an aircraft from standing to 5 times the speed of sound in the atmosphere. The engine then switches to rocket mode, which could push it to speeds of Mach 25, nearly 20,000 miles per hour. Such systems are technically possible, but the amount of oxygen needed for fuel would make such an aircraft impossibly heavy. Instead, Sabre sucks the oxygen it needs from the atmosphere and uses it on the spot, with technology that has worked so far. The free piston engine. Free piston engine is a linear, crankless, internal combustion engine, in which the piston motion is not controlled by the crankshaft, but determined by the interaction of forces from the combustion chamber gases, a rebound device, and a load device. The purpose of all such piston engines is to generate power. In the free piston engine, this power is not delivered to a crankshaft, but instead extracted through either exhaust gas, pressure driving a turbine through driving a linear load such as an air compressor for pneumatic power, or by incorporating a linear alternator directly into the pistons to produce electrical power. The 5-stroke engine. The engine concept, which was invented by Gerhard Schmitz, has been developed. 2 overhead camshafts operate the conventional coil spring valve gear, with the HP camshaft running at 0.5 times crank speed and the LP camshaft running at 1 times crank speed. The engine is also turbocharged to increase the engine's rating. Some advantages of the 5-stroke concept are a secondary cylinder provides an additional expansion process, enabling extra work to be extracted, hence increasing thermodynamic efficiency. The compression ratio can be reduced to delay knock onset with a reduction in performance, and the engine uses 100% conventional technology and so requires no new manufacturing techniques. The Duke engine. The Duke engine is an axial design, meaning that its 5 cylinders encircle the drive shaft and run parallel with it. The pistons drive a star-shaped reciprocator, which nutates around the drive shaft, kind of like spinning a coin coming to a rest on a table. The Duke engine is an advanced internal combustion engine, delivering high thermodynamic efficiency, complete fuel flexibility, runs on any suitable spark ignition fuel, negligible first and second order vibrations with huge weight and size savings. It is considerably less complex internal combustion engine, and it is suitable for marine, inboard and outboard, light aircraft, generator/utility, and military applications. The Nissan Dig TR. The ultralight Dig TR 1.5-liter 3-cylinder petrol engine is small enough to fit in a carry-on luggage and boasts a power-to-weight ratio better than the engine of a Formula One racer. As part of the design strategy, both the petrol and the electrical parts of the power plant go through the same 5-speed gearbox. The Dig TR's base engine is 500mm tall by 400mm long by 200mm wide, but it puts out power like a fire hose at 400 horsepower. Yeah, that's right. This tiny 3-cylinder engine is putting out up to 400 horsepower. The Hootland Kugel motor. The Hootland is designed to supplement the electrical power of a hybrid car. The prototype Hootland that's been making the rounds produces about 104 horsepower, but unlike a traditional gasoline engine, Dr. Hootland claims that the design is easy to scale to suit almost any power need. It's built from just a fraction of the parts of a traditional engine, which helps achieve the goals of efficiency and economy, since there are fewer parts to produce and assemble. That means in part the Hootland achieves more than 30% efficiency. Traditional engines, by comparison, achieve only about 20% efficiency. Think about that the next time you fuel up. The free valve engine. The free valve concept, also known as the fully variable valve actuation, offers the unique ability to have independent control of the intake and exhaust valves. For any engine load criteria, the timing of intake and exhaust can be independently programmed. The system can then decide which one to use to maximize performance or minimize fuel consumption and emissions. This allows greater degree of control over the engine, which in turn provides significant performance benefits. While the fully variable valve actuation concept has been widely tested, no manufacturer has been able to implement it in a large-scale production due to various technical problems along with packaging disadvantages and higher cost. The free valve technology shows great promise of overcoming these challenges in a cost-effective way. Which engine was your favorite? Make sure to tell us in the comments below. I like the Sabre engine myself. It would be pretty cool to take a trip to space without actually being an astronaut. And as always, thanks for watching Mind's Eye Design.